In the last class, we talked about effective interest rate and effective discount rate. This class, we are going to talk about nominal interest and nominal discount. Nominal interest rate and nominal discount rate is the opposite compared to effective interest rate and effective discount rate. Nominal rate of interest is noted as IM. So sometimes payments are made for a period less than a year, for example, monthly or quarterly. The nominal rate of interest compounded m times a year is denoted as IM, where m denotes the number of compounding period per year. Common period used are monthly, quarterly, semi-annually, and annual. In practice, a nominal rate of interest is given along with how frequently interest is compounded. Now let's look at an example. If m equals 12, so it means the nominal rate compounded monthly. For example, if interest is quoted as 6% compounded monthly, then we would write I12 equals 6%. And 6% is called the nominal rate of interest. We then get the monthly effective interest rate as I12 divided by 12, so it's equal 0.5%. If m is equal to the nominal rate compounded semi-annually, then the semi-annual effective interest rate would be I2 over 2. Similarly, if m is equal to 4, so it means nominal rate compounded quarterly effective interest rate would be I4 over 4. Similarly, you can see nominal rate compounded biannually, and the biannual effective interest rate is as such. Okay, so based on the previous illustration, for any of the nominal interest rate, you can always convert it to effective interest rate, and you can use this formula here, where IM over M is the M's effective rate of interest, and I is the equivalent annual effective rate of interest. The rate that will given the same result if compounded only once in a year. The nominal rate is an artificial rate, while the effective rate is not. It tells you what you really earn with compounding in a year. In general, I is greater than IM. So for example, if you are deposit $100 in the bank and you are making 1% each month, if it's a simple interest rate, you know at the end of the year you will make 12%, which is giving you $112. But since it's if this is rate is just a nominal interest rate, IM is equal 12, then each month you will earn 1% each month, monthly. So it means your whole year you will earn 1 plus 1% to the power of 12. So 1.1 to the power of 12. This number, if you use a calculator and calculate that, you will see it's definitely higher than 1.12. This is because the interest you earn in each month is used as the principal to make additional interest. This is the same concept we talked about before, like from simple interest to compound interest. Here is just we further divided the time period of 1 year into monthly. So the more frequent you get the interest, the higher you will get the final interest. Now let's look at some more examples. Example A, find FV, which is the future value if annual effective interest rate is 6%. If you deposit $1 in bank for 1 year. So this is very simple. We already done this. And then the effective interest rate is 6%, but it's annual. So in this case, effective interest rate is the same as nominal interest rate. So your future value would be, let me activate the pen. The future value would be $1 plus 6% times 1, so it's 1.06. Let's look at the second question. Find FV if a nominal interest rate 6% common monthly if you deposit $1 in bank for 1 year. This is exactly the example that I show you earlier, except this nominal interest rate is 6% compounded monthly. So your FV would equal 1 plus IM over M to the M power. So it's 1 plus 0.05 to the power of 12. 0.005 times. Okay, so this you will calculate yourself from here. The third example, suppose interest is credited monthly and the nominal rate is I12 equal 0.09. What's the effective rate? That's the same question, except this nominal rate is I12 equal 9. So it's 1 plus I09 divided by 12 and to the power of 12. So I'm not going to calculate value. You can calculate it based on your calculator. And the fourth question is suppose 2% per quarter. What's the annual nominal interest rate? What is the annual effective interest rate? And so if they said 2% per quarter, so nominal interest rate will be 2% times 4, so it's 8%. We would say nominal interest rate is 8% compound quarterly, and the effective rate will be 1 plus 2%, since it's already and to the fourth, because you will get a compound each quarter, so it's 1.02 to the fourth power. Okay, now let's look at a couple more examples. Example E, interest is paid semi-annual and is equivalent annual effective rate of interest is 10.25%. Find the nominal interest rate. So in this example, the question is reverse of what we already did before. In the previous example, it always gives you the nominal interest rate and ask for effective interest rate. But now it gives you the effective rate but ask for nominal rate. But still we can use the same formula. 1 plus I is equal 1 plus 10.25%, and it's equal 1 plus IM to the 2 and 2 power. So we can do the square root on both sides, left and right side equation. On the left side is 1.1025, and right side is 1 plus IM divided by 2, and the left side is equal 1.05. Right side is IM divided by 2, so IM is equal 10%. Okay, the second example. Suppose that the annual nominal rate convertible quarterly is 4%. What's the annual effective interest rate? And what's the nominal rate of interest compounded monthly? So the first question is still very similar to what we did. So it's 4%, but it's compounded quarterly. So the effective rate would be this, and this would be 1 plus I. Here you can get I is equal 4.06%. Then the second question is asking what's the nominal rate of interest compound monthly. So we are saying if this is the amount, 1 plus I equal 1 plus I 12 divided by 12 to the power of 12. And then you can we already know I in this case is 4.06%. We can solve the equation and get I12 would equal 3.987. So we have to talk about nominal rate of interest. Now let's talk about nominal rate of discount. The note is DM. Nominal rate of discount compounded m times a year is denoted by dm. If you were using a discount rate of 2% per quarter, you could refer to this as a nominal discount rate of 8% convertible quarterly. So the first question, will the annual effective rate of discount be 8%? So the answer is no. It's similar to the concept of when you have effective rate of interest 8% and the nominal rate of interest of 8%. They are different. In general, the effective rate D is less than dm. Usually, the nominal rate of discount is given along with compounding frequency. Example, if the discount rate is 6% compounded monthly, then we write D12 equals 6%. And 6% is called the nominal rate of discount. We then get the monthly effective discount rate as D12 over 12 equal 0.5%. I think this is a relatively easy concept here. Okay, below are some formulas that you will have to know. First is the formula related to nominal discount rate and effective discount rate D. So 1 minus dm over m to the power m equal 1 minus d. This is very similar to the effective interest rate concept where it's 1 plus im over m to the power of m is equal 1 plus I. So the discount is just a minus d in this case. Okay, the conversion of a nominal interest rate convertible m times per year to an equivalent nominal discount rate convertible p times per year. This is exactly what I just write. You have a 1 plus I, which is can be equal 1 plus im divided by m to the power of m, or you could also be 1 minus dp over p to the power of negative p. Okay, now let's look at some more examples. Find the effective discount rate for a nominal discount rate of 8% convertible quarterly. So we would have 1 minus dm in this case 8% divided by 4 to the fourth power would equal 1 minus d. The rest you can use a calculator to get d is equal 0.000776. The second example, calculate FV of $100 at the end of 10 years at a nominal interest rate of 7%, compound semi-annual for the first 4 years, and 5% compound quarterly for the next 6 years. So basically, in the 10 year, there are 2 different interest rates. We just need to calculate the first 4 years, and once we know the value at the 4th year, then we can start from this 4th year doing another of accumulation of interest to get to the final point. So future value of $100 times 1 plus 7% divided by 2, since it's semi-annual, to the 2. But since it's 4 years, so basically you have to utilize this rate to the 4th power, and then you do 1 plus 5% divided by 4, because it's quarterly, to the 4th power. But then because this is the rest of 6 years, so you do this. I think this will give you the answer of 177.4 eventually. The third example, calculate present value of $100 due 5 years from now at a nominal rate of interest 6% compounded monthly. So again, we write out this 1 plus 6% divided by 12 to the 12th. This is the effective rate in a year, but since this is in 5 years, so basically you have to do this rate to the 5th power, which is equal to 12 times 5 the power, so 60 powers. Then this would be present value of $100 is due in the future. So if our future value is $100, because it says $100 due 5 years from now, then your PV can be calculated as $100. So PV times all these, FV equals PV. PV will be $100 over this 1.05 to the 60th power. Okay, example D. Calculate the future value of $100 at the end of 8 years at a nominal rate of discount of 5% compound semi-annually. So if we only have 1 year if first we calculate the 1 year interest rate would be 1 plus 5% divided by 2 to the power. But since it's an end of a year, so you will have to do another 8th power. Therefore, the result is 149.94. Another example, find the PV of 5,000 due in 10 years at an effective rate of discount of 9% annually. 9% annually. So 5,000 present value, by the present value of 5,000 due in 10 years. So its future value is 5,000. The future value equal 5,000, which equal present value times 1 minus 9%. Since it's annually, it's just to this 10. From here we can get PV is equal 1947. PV is equal 1947. 1947. I will hand out another handout for you guys, which has a little more explanation in the calculation, since it's very difficult to write this on the screen. So I tend to write it very shortly. But in my handout notes, you will find out that they have a little more writing there to explain the whole process. Okay. Find the PV of $100 in 5 years at a nominal rate of discount of 5% compounded and semi-annually. So 100, again 100, and discount at 5% compound. So times 2, then you will have to have another fifth power, which is equivalent to 2 times fifth power. So which is equal 128.81. Okay, last 2 examples. Before I move on, I want to just explain that one thing I use. Maybe you guys are not familiar, but it's the property of exponents. When you have a, then you have raised to another m power, then it's equal amm. This is being used in several of my calculations. Maybe I did not explain it clearly, but I just want to explain it here. So in this example, 8,000 due in 6 months and the nominal discountable. So it's 1 minus 12% because it's monthly divided by 12. So if you raise it to, this is just 1 year's rate, then supposedly I would, because it says 6 years, I would have another to the power of 6. So it's equal 8,000 times 1 minus 1% to the 1272. Okay, you will get an answer to be 3879.9. Okay, next example, find the MV of $100 in 15 years at a nominal rate of interest of 12% per annum, convertible quarterly. Future value, so it's equal $100 times 1 plus 12% divided by 4 because it's quarterly raised to the fourth power. Then it says in 15 years, so I will use the exponents, the property exponents multiply 15. So you got 589.16. That's it for this.